in parentheses.
Okay, so we are talking about adding and subtracting square roots today. The principles apply for all roots. Step 1 is to simplify all of your roots. We've done a couple of lessons on that. And step 2 is to combine like terms, which are also sometimes called like radicals. So I'm going to show you what that looks like down here. So if I have the square root of 3 plus 2 square root of 3, these would be considered like terms because they both have a square root of 3. So this is like taking x and adding 2x. So let's do that first. If I have an x and I add 2x to it, how many x's do I get?
3x.
3x. Because
that was right?
That is right.
Oh.
So when you have one that doesn't have a number in front of it, it's like adding 1. So if I have 1 square root of 3 plus 2 square roots of 3, you could actually rewrite it with a 1 in front if that helps you. Some people enjoy that.
Sure.
Then you would add the 1 and the 2 together to get 3, but the square root of 3 doesn't change. It's like an x. So it just stays the same.
That kind of confuses me because if I were going to put that in my mind, I would have made the 2 3's into a square.
Yeah, so you can't add anything that's inside the square root symbol. Think of those as being like in jail.
Gotcha.
They're like stuck in there unless you can simplify a radical to bring something out. So I'm going to show you another example of a longer example. If I have 2 times the 2 square root of 5 plus 7 square root of 5 minus 4 square root of 2.
Okay, hold on for 1 second.
So take a second to write it down.
When you go up a second for on the 3 square root 3, how did you get that?
1 plus 2 is 3. The square root of 3 just follows. It's like adding the x and 2x to get 3x. You add the coefficients, which is the numbers on the outside. The number on the inside stays the same, just like x didn't change. So write this problem down, and I want you to think in your heads which terms are like terms. So basically, which ones have like radicals, like roots?
2 and 7.
Okay, so the 2 that have square roots of 5, this one and this one, would be like terms because they both have the square root of 5. So all I do is add the 2 and the 7 together. So 2 plus 7 is 9. I'm going to put that over here. So 9 radical 5. And then the minus 4 square root of 2 just is going to stay minus 4 square root of 2. So this would be kind of like if I had 2x plus 7x minus 4y. If you want to think of it as something that we've done before, you could add these together to get 9x, but the minus 4y would stay separate because it's not like terms. It's exactly the same idea that we used with variables. It's just the radicals are taking the place of the variables. It's not bad. Now, you cannot add or subtract if you have any things that need to be simplified. So let me give you one. So we're going to have the square root of 45 minus 2 square root of 5. So we need to check under the radicals and see, could 45 or 5 be simplified? So we would take 45 down here and try to birthday cake that. So what prime number do you want to use for 45? 5, 9.
3,
Wait.
3, 1.
Okay, now write it down. Because you said it really fast, but you got to write it down. So this would be the square root of 3 times 3 times 5. So if we look at that, I do have a pair. Since it's a square root, we want to take them out in pairs. So how do I rewrite that?
3 squared times 5.
So it'd just be 3 square root of 5. So we're taking the square root of 3 squared, which just makes it 3. And then we have the radical 5. And then do I need to do anything with this? Minus 2 radical 5?
Yes.
I mean, you could take 5 and birthday cake it. I'm just going to get 5.
Well, no,
So we could just add that on the end, minus 2 radical 5. I get what you're saying. But we can't simplify it, was what I was going for, because 5 is already a prime number. So then we look at it and we ask ourselves, are these like terms? Can I subtract?
C.
Yes. So if I take 3 square roots of 5 and subtract 2 square roots of 5, how many square roots of 5 will I have?
Uno.
1. So I can either write 1 square root of 5, or you can leave the 1 off and just make it square root of 5. Because if there's one of them, it doesn't have to have a coefficient. Just like 1x and x would be the same thing. You could write those either way. And when we're grading assignments, I would take those either way.
I like taking notes.
Okay, so let's do another one. Let's say that I have 4 times the square root of 8 plus 3 times the square root of 32 minus the square root of 2. And talk about how this is going to happen. So first we want to birthday cake 8. So I'm not going to go down too far. We still need to fit one more example, but I'll just do it here small. So 8, what prime number goes into 8?
2.
2, and then I get 4, divide by 2, I get 2, divide by 2, I get 1. So there's already a 4 out there. And then I'm going to have 2 times 2 times 2. Maybe I should do this over here. So I have room. So over here we'll have 4, and then we have the square root of 2 times 2 times 2. So this pair of 2's would come out. So I already have the 4 there. That has to stay. But then I'm also going to bring out a 2. So it's going to be 4 times 2, and there's a 2 left in there. So if there's a number already there, or bringing a number out, you multiply those.
So it would become 8.
So it would become 8 square root of 2.
And I'm guessing we do that for all of them. So for
Yep,
32,
so for 32, we need to birthday cake that one as well. So 32 divides by 2, get 16, divide by 2, you get 8, divide by 2, you get 4, divide by 2, you get 2, you get 1. So there's 1, 2, 3, 4, 5 2's. So I'm going to put plus 3, and then I'll do 2 times 2 times 2 times 2 times 2. So if it's square roots, I guess that almost looks like I made a cubed root. Let me rewrite that. It's plus 3 and then square root. So we can do a couple of pairs here. There's a pair. There's a pair. So I already have a 3 out there. What else is going to go out there?
2 2s.
A 2 and a 2. And you're going to multiply those together. And what's still under the radical sign?
2.
A 2. So 3 times 2 is 6. And then times 2 is 12. So that'd be 12 square root of 2. And then don't forget the original problem. We had minus the square root of 2. Now I already know 2 is prime. So I can just tack that on the end. Minus square root of 2. So that came from over here in the original problem. So I did not have to simplify all of them. But look, they all have a square root of 2. So that means they all get combined. What do you think?
So I'm guessing the negative has a 1 if I'm considering.
Yes, so we could put a little 1 there if you want
So then when you
to.
add it all up, it should be 19.
So 8 plus 12 is 20, and then subtract 1. So 8 plus 12 is 20. 20 minus 1 is 19 square root of 2. So anything that comes out to be like terms, so this is why we have to simplify them first before we add. You need to get it down to as the smallest it can get on each of these before you can combine. And where this really comes in handy is in some higher level formulas, so that you can make some formulas from something long to something shorter. We have one more example, and then we'll be done. So down here, I'm going to put some negatives in. We're going to do negative 3 square root of 12 plus 3 square root of 3 plus 3 square root of 20. So are any of these already simplified that we know we're not going to have to birthday cake or do anything to? This one. So this one is already simplified. So I'm not going to have to do anything with that one. But I am going to have to do something with the 12 and the 20. So I'm just going to come over here and birthday cake the 12. Find the prime factorization of 12 is the more precise way to say that. So what goes into 12 that I can divide? 6 isn't prime.
3. 6 is the next.
Okay, so 3
4
goes in 4 times.
2
2,
2
1. Okay, so this would be, so the
way-
negative 3 is still out there, and then I'm going to have the square root of 2 times 2 times 3. So I do have a pair of 2's. So I'm going to have negative 3 out there, and now that's going to be times 2, and there's still a 3 left in the radical. So we can finish that up. Negative 3 times 2, negative 6, square root of 3. And we already have the 3 radical 3, so I can go ahead and write that just down here on this last line so I don't forget about it. You always want to go back to your original problem. After you birthday cake something and do all this, you're like, okay, I'm done. Don't forget that there's still addition to happen here. So let's do 20 really quick because I know that that's not prime. So you can go into 2, get 10, divide by 2, you get 5. By 5, we get 1.
6 square root.
So you're going to have 3 square root of 2 times 2 times 5. So you're right, that's going to be a pair of 2's we can bring out. And so that would be 3 times 2, and the 5 is still inside. And this was plus, so I should put that plus there. So plus 6 square root of 5.
I think I did that right.
Here, hold on 1 second. You're going way too fast.
Okay. So while we're waiting, look at it, identify what things can be added together and what cannot. So basically the steps
Wait,
are,
for 20, can I just do 5, or does it have to do what you did?
so you have to birthday cake it. Did
Yeah,
you do
I know
that?
that.
He can do,
Birthday
he's
by
meaning
5.
like if I can divide by 5 and to get,
Yeah, you could do 5 and then 2 and 2. It's going to come out the same as long as you're dividing by prime numbers.
and if you think about it, it's just going to be
It's still going to be 5 and 2 and 2. It works out the same. Because you will always get the same numbers when you do the prime factorization. Okay,
Hold on 1
so,
second. I'm not gonna-
you know, I could always make you a copy when we're done if it takes that long.
yeah,
The
but-
main thing is watching and absorbing
I-
because we're recording.
Okay, hi JP.
It's
Oh,
not
we're-
necessarily
we're-
for him. Okay, so which parts can we put together? Which parts are like terms? Go ahead.
negative 6 and radical 3. Right?
Okay, so the parts that have the radical 3. So this part and this part are like terms because they have the square root of 3. So I'm going to take negative 6 and add 3. What is negative 6 plus 3?
Negative 3.
Negative 3. So I'm going to get negative 3 radical 3. So that part just goes along. And then I will just tack on the plus 6 radical 5. I cannot combine those because they are not like terms.